I do that? I was on a roll too. But these are your new vocabulary. Okay, pretty simple, pretty easy. The things that we're going to be most concerned with are our 6 trigonometric ratios for right now. Okay, some other things that you definitely want to be aware of. Okay, some of them you might have heard in Algebra 1, geometry a little bit that way. So, like we said, the Pythagorean theorem. Okay, that states that a squared plus b squared is equal to c squared. And this is for side lengths of a right triangle. Okay, it's the easiest way to find the given side length. A and B are the legs. Okay, where C is the hypotenuse. With the hypotenuse being the greatest side length. Okay, so your hypotenuse is where C squared is. Okay, that's also the one that's opposite of the right angle. So hypotenuse is right there. Okay, with this one being the leg, this one being the leg. Okay, with that, we're going to have to be doing square roots, okay? Because once we use the Pythagorean theorem, we take the square root to find the actual length of A, B, and C. Like if this is a leg, this is a leg, and this is the hypotenuse, we would have to take the square root to be able to find what C is. So that is going to cause you to rationalize the denominator. And you'll hear that term quite a bit. What this means, rationalizing the denominator. Anytime, so say we have 2 over the square root of 2. I'm just using those. Just simple, easy. Anytime we have a radical or a square root sign in the denominator, we have to rationalize it. And what we do is a fancy thing. Well, it's not really fancy. It's just more or less manipulating the equation to remove the radical. Okay, more or less we're going to multiply it by 1, but it won't look like we're multiplying it by 1. So I have square root of 2 in the denominator here. What I'm going to do is multiply both the numerator and the denominator by the radical that is in the denominator. And what this does is it removes the radical. Like the square root of 2 times the square root of 2 is basically the square root of 2 squared, which eliminates the radical to show that our denominator would be 2 and our numerator would be 2 square root of 2. Okay, and it would look something like that. This is known as rationalizing the denominator. We multiply both the numerator and the denominator by the radical that is in the denominator. Okay, because we cannot have this happen. Okay, we do that, the radical goes away, we're just left with the radicand, and the numerator absorbs the radical. So it's 2 square root of 2 over 2. Okay, making sense on rationalizing the denominator so far? The last thing that we have, okay, is since we are working with square roots, especially in the Pythagorean theorem, we want to get them to their simplest but most exact form. Okay, so in side lengths, we're not going to be using decimals very much. Okay, in the side lengths, when it's like solve this right triangle or solve for this side, we're actually going to leave it as radicals. So what that requires you to do is the power property of radicals. Okay, and what that states is if you have the square root of variable a times variable b, that can be broken down to the square root of a times the square root of b. Basically, it allows you to split stuff. So in a situation like this, say we're taking the square root of 117. Okay, 117 is not a perfect square. right? So if we were to just take the square root of it, we'd have a decimal, which is not the exact answer, right? Because eventually we'd have to round because it's irrational. What we would do is we're trying to find a perfect square that multiplies into 117. Okay, so your perfect squares are like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 225. Oh, 196, and then 225. Okay, those are your perfect squares going up to 15. What I mean by perfect square is 3 squared is 9, 2 squared is 4, 15 squared is 225, 14 squared is 196, 13 squared 169, and so on. Okay, so stuff that you've heard, we're just going to use these to help break this apart. So which of these numbers would actually multiply evenly into 117? The answer to that would be 9. So the square root of 117 can be broken down into the square root of 9 times the square root of 13. 9 times 13 is 117. Okay, at this point, we know the square root of 9 is 3. So our exact answer for the square root of 117 is 3 times the square root of 13. We can't break 13 down any farther. But that is the simplest, most exact answer that we can give. Okay, and that comes from the power property of radicals. So just know that we can split it up. We're looking for a perfect square that goes into it, and then we're able to take one of them, and we'll be left with a radical. Okay? Give you just a second to write that down. If I were you, I would write down my perfect squares. Okay? Just because it makes it a little bit easier to handle with the power property of radicals. Taking notes, Nick? Got anything to take notes with? Yeah, take them on your notebook. Because think about it. I'm asking you to turn in your lecture notes, right? Yeah. Rather than having to rewatch it. Save yourself a little bit of time. Be efficient. All righty then. Okay. Back to the slides. Okay, so once again, here's your vocab. And then here are the 6 trigonometric ratios. Okay? So if theta is a measure of an angle, of an acute angle of a right triangle, then the following trigonometric functions involving the opposite side, the adjacent side, and the hypotenuse are true. Okay, so keep in mind if theta is here, right? Theta is in the lower right. So the side that is opposite of the angle is the opposite side. The side that is touching theta is your adjacent side. And then once again, your hypotenuse is always across from the right angle, the 90 degrees. So what this sets up, okay, it allows us to take sine, cosine, and tangent. So if we look at the sine ratio, sine of theta is equal to the opposite side over the hypotenuse. So in this case, it would be 4 over 5. Okay, cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. You can see they're reciprocal because the numerator and denominator are flipped. If we were to multiply sine times cosecant, we would end up with 1, okay, as an answer. because our opposite sides, we have one in the numerator, one in the denominator. The denominator and the hypotenuse, numerator, hypotenuse, if we multiplied those together, it would all break down to be 1. Okay, then that brings us to cosine. Cosine is the adjacent side over the hypotenuse. Okay, adjacent over hypotenuse. Then secant is the reciprocal to cosine. Okay, where you have hypotenuse over adjacent. And you can see how they're flipped. So in this case, if theta is here, cosine would be 3/5. Okay, secant would be 5/3. Then you have tangent. Tangent is opposite over adjacent. The reciprocal of tangent is cotangent, which is adjacent over opposite. So in this case, our tangent of theta would be 4/3, the opposite side over the adjacent side, and the cotangent would be the adjacent side over the opposite side. Okay, so this, it's really not hard. I don't want to necessarily say it's not hard. It's just a lot to remember. Okay, but there's a little trick that my math teacher taught me when I was in high school. Still use it today. And it's just a phrase. It's called SOHCAHTOA. So, ka, toa. Okay? So stands for sine. It represents SOH. Sine is opposite over the hypotenuse. Ka is representative of cosine, CAH. So it's the adjacent side over the hypotenuse. Tangent is, or TOA is representative of tangent because you have the opposite or the adjacent side. Okay, and from there, we can flip them into their reciprocals. An easy way to remember the reciprocals is that if we look at them as in groups of 2, a trig function and its reciprocal function, one of them will say co. Okay, so what I mean is that sine is the reciprocal of cosecant. Okay, cosine is a reciprocal of secant. See how co is on this side, it's representative, and then tangent and cotangent. So if we look at them in pairs between one of the ratios of the 2, you will have the preverb or the pretext of co. Okay, sine, cosine, tangent, cosecant, secant, tangent, or cotangent. Very pretty simple stuff so far. But from there, we can do a lot of stuff with triangles. Okay. I'll give you just a couple more seconds to write that stuff down because that's like the heart. That's the key concept. And I need to catch my breath. Been out of shape. Winter break took its toll on me. All righty. Where'd you go? Clicker. Where did you go? What did I do with it? I just had it. Dang it. Okay. I'll do it without it. Fine. All right. So we're off to our first question. It says find the values of the 6 trig functions for angle G. Okay, so angle G is over here. So this is the opposite side. This is the adjacent side. This is the hypotenuse. Okay, so 24, 32, and 40. So starting off with the sine function. or the sine ratio. Sine, once again, is opposite over hypotenuse. So looking at our diagram, sine is going to be 24/32. Okay, or SIN is how it's abbreviated. And that is 24/40, sorry. Okay, but it's not in its simplest form. We can solve that even farther. It would go down to 12/20, which would also be equal to 6/10, 3/5. Okay, cosine of angle G. Okay, cosine is adjacent over hypotenuse. So the adjacent side here is this 32. The hypotenuse is still 40. So cosine is equal to 32/40. But we would have to simplify it even further, which would break it all the way down to 4/5. Okay, and then our final one of the main three is tangent, abbreviated TAN. That is the opposite side over the adjacent side. So 24 is the opposite side, 32 is the adjacent. So that is 24/32. Or 3/4, because we have to bring it to the simplest terms. We have to simplify each one of our fractions. Okay, we can't just leave them sitting out there. That's really kind of frustrating. There it is. Duh. Okay. So I got three of them. Okay, I got the main three. The three that most people are worried about. Here's where knowing which ones are reciprocals definitely helps. So sine, the reciprocal function of sine is cosecant. So, and since I know that cosecant is the reciprocal of 3/5, I know that it's going to be 5/3. Okay, I can flip that. Okay, I can improve and make myself more efficient. Cosine has the reciprocal ratio of secant, abbreviated SEC. So if cosine is 4/5, secant is 5/4. Okay, tangent has the reciprocal of cotangent. It's abbreviated COT. If tangent is 3/4, cotangent is 4/3. Okay, and that's why it's helpful to know those reciprocal functions. I can find just three and then speed my way through as long as I match them up properly. How do you find the opposite side and the adjacent side? Okay, that's a good question. It's really just a matter of appearance, right? Okay, so if we're looking at it, we were given this function, and it gave us the angle here. So angle G, the opposite side will never be touching or a part of angle G. It'll always be the opposite. Okay, it's what it opens up to. Like if you can think of the angle being a mouth, okay, the mouth would open up to be the 24. The adjacent side will always be one of the sides that creates the angle. Okay, so it's touching. So that's why 24 is the opposite side, 32 is the adjacent side. Those are only, yes, this is right angle trigonometry, bud. Yep. Everything that we have will have a right angle. Okay. And then your hypotenuse, once again, is always the side that is opposite of the right angle. Okay, it's the biggest side length too. Leave them, you'll have to simplify every fraction. Okay, it won't be accepted if you just break it down. You have to simplify it. Okay, So for this triangle, the leg opposite of angle G is HF and the leg adjacent to G is GH. They're just identifying it. The hypotenuse is GF. Okay, so 24 is the opposite, 32 is the adjacent, 40 is the hypotenuse. Okay, so since sine of G is the opposite over hypotenuse, 24 40ths or 3/5. Like I said, you have to break it down. Okay, you have to simplify. Cosine is the adjacent over the hypotenuse, or 32 40ths or 4/5 once it's simplified. Tangent, 3/4 after simplifying it. Cotangent, 4/3. Once again, those are reciprocals. Okay, tangent and cotangent are reciprocals, so you can see how they're just flipped. Cosecant is the reciprocal of sine. So if we multiplied 3/5 and 5/3 together, we would get 1. Okay, and then secant, the reciprocal of cosine, is 5/4. Okay, like I said, you can go pretty fast if you're good with those first three, and you remember how they align. Okay, with their reciprocal ratios. So, and that would be our final answer. Okay, so find the value of the 6 trigonometric functions for angle A. So angle A is here. Our opposite side is 20. The hypotenuse is 25. The adjacent side is 15. So on this one, if we're looking at sine of A is going to be 20 25ths, which is also going to break down to 4/5. 20 25ths simplified is 4/5. Cosine of A is the adjacent side of 15 over the hypotenuse of 25. So 15 25ths, which will simplify down to 3/5. Tangent of A is the opposite side over the adjacent side. So 20 over 15 or 4/3. Okay, now if we're looking at cotangent, secant, and cosecant, once again, since they're reciprocals, and we've already found what sine, cosine, and tangent are, we can just flip these to get cotangent, secant, and cosecant. Okay, once again, they're flipped. So if we multiply these together, they would equal 1. Same thing here, same thing here. It's the joy of the reciprocal functions. You can do it pretty quickly, pretty simply. So now it's just time to pick the answer that has all those. And that answer is A. Okay, so you can see how these work. Pretty simple, pretty smooth. Okay, here it's kind of it's a little bit tricky, but it's not necessarily the worst. Okay, it says if tangent of A is 5/3, find the exact values of the 5 remaining trigonometric functions. Okay, and Algebra 2 book uses letters to identify angles. Sometimes you might hear it as theta and like pre-calc and actual trig, but it's just a way to identify the angle. So for a question like this, okay, it says tangent of A. We don't really care where A is. We just know that tangent is going to be 3/5 or 5/3, sorry. So opposite over the adjacent side with my 90 being there. And then I have my hypotenuse. Okay? So from this, in order to find my other side is where I have to use the Pythagorean theorem. Notice how I have 2 legs. I do not have the hypotenuse. Right? Tangent's the only one that doesn't involve the hypotenuse. So I would use the Pythagorean theorem. 3 squared plus 5 squared is equal to c squared. Okay? 3 squared is 9. 5 squared is 25, still equal to c squared. So c squared is equal to 34 once I do the math. Okay, to find out what the value of c is, I have to take the square root. Okay, so c equals the square root of 34. Okay, now I want to think to myself, is there a perfect square that goes into 34? So 4, no, doesn't go into it because 8 times 4 is 32. See, 9 doesn't go into it. 16 doesn't go into it. 25 doesn't go into it. And I'm thinking about multiplying into it whole. So since a perfect square does not go into that, I can't do anything with it. So I have to leave it as a square root of 34. Okay? So from now I know what I can do to figure out the rest of my trig functions for a. Remember, tangent was 5/3. That was given to us in the question. Since we know what tangent is, we automatically know what cotangent is. Tangent is 5/3. Cotangent is 3/5. The reciprocal function. Okay? Sine of a is the opposite side over the hypotenuse. So that is going to equal 5 to the square root of 34. But here I have to rationalize the denominator. So I'm going to multiply both by the square root of 34 to get my final answer of 5 square root of 34 over 34. Okay. Cosecant is just the reciprocal of sine. So that's the square root of 34 over 5. Okay, cosine is the adjacent side over the denominator, over the hypotenuse. So that is 3 over the square root of 34. Once again, I have to rationalize it. So I would be left with 3 square root of 34 over 34. And then secant, as my last one, would be the square root of 34 over 3. Done and done. Okay, so we use the trig function to draw it up. And the key thing was when you're doing these questions, don't be afraid to draw. Okay, draw diagrams. They're pretty simple, pretty easy. Okay. Use the Pythagorean theorem to find c. So the square root of 34 is c. Length can't be negative. Now we find the rest of the trig function. Sine is opposite over hypotenuse. 5/34. So 5 over the square root of 34. Then we rationalize the denominator to get our final answer there. 5 square root of 34 over 34. Then we have cosine. The adjacent side was 3. So 3 over the square root of 34. Once again, we're going to have to rationalize it because we have a radical in the denominator. Okay, and once we're done with that, it'll be 3 square root of 34 over 34. Okay, now our next one's cosecant is square root of 34 over 5. Okay, or you could just flip the original sine function before we rationalize the denominator, make it quick. Secant, the reciprocal of cosine, is square root of 34 over 3. And cotangent, the one that was given to us in the problem, since tangent was 5/3, cotangent has to be 3/5. Okay, so that would be our answer for this question. Okay, if sine of b is 2/3, find the value of the cosine of b. Okay, this one is basically the same thing. If we erase it, and I'm going to use the same diagram, I'm just going to replace letter, A to B. So sine of B is 2/3. So that means the opposite side is 2. The hypotenuse is 3. So we'd have to use the Pythagorean theorem, but here we have the hypotenuse. So 3 squared is equal to 2 squared plus, let's say, a squared. Make it simple, 3 squared is 9, 2 squared is 4, plus a squared. If we isolate the variable, we have a squared is equal to 5. Take the square root. So a is equal to the square root of 5. So that's this right here. Okay, and then the question asked us if sine of b is 2/3, what is the value of cosine of b? Well, cosine of b is the adjacent side over the hypotenuse. So that would be the square root of 5 over 3. Okay, so you can see the Pythagorean theorem is what you use to figure out the other lengths of the sides. Okay, these are your common reoccurring or special triangles, special right triangles. You're going to want to make good notes on these. As we get to graphing and to make it a little easier on you, you can actually memorize these if you wish. Sine of 30 is 1/2, always. The sine of 60 is the square root of 3 over 2, always. And what this does is it allows you to expand these right triangles. Okay, these are the ratios of any 30-degree angle in a right triangle. Doesn't matter what the side lengths are. If you have a 30-degree angle, it's going to match up with sine of 1/2 because it's a ratio of side lengths. Okay, cosine of 30 degrees is the square root of 3 over 2. Cosine of 60 degrees is 1/2. You can see with sine and cosine, they equal each other, okay, and work a little opposite. Sine of 30 is equal to cosine of 60. Cosine of 30 is equal to sine of 60. Then you have tangent of 30 is square root of 3 over 3. And tangent of 60 is just the square root of 3. Okay, and once again, that's the ratio amount. Okay, they're all ratios. Then you have 45, 45, 90-degree triangles, where the sine of 45 is the square root of 2 over 2. Cosine of 45 degrees is the square root of 2 over 2. And the tangent of a 45-degree angle is always 1. So I'll give you a couple minutes to copy these down. They're just handy to have. Make you way more efficient when we get to graphing these things. Why don't you just do your job? God, that makes me so mad. Oh, sorry. Okay. So here's the next type of questions that you'll be handling. They're not really hard. You just got to kind of think about it, and you got to really apply the trig ratio strategically. You always want to use the one that is representative. Okay, so it says use a trigonomic function to find the value of x, round to the nearest tenth if necessary. Okay, so right here, we have a 60-degree angle that's down in the bottom right side. Okay, the opposite side of that 60 is x, and the hypotenuse is 12. Okay, So we want to think to ourselves, what trig ratio incorporates the opposite and the hypotenuse? The answer to that is going to be sine. Okay, so we can set this up as this. That the sine of 60 degrees equal to x over 12. Okay, and now we want to solve for x. Okay, well, all we have to do is just isolate the x variable. So it's x divided by 12. To get x by itself, we need to multiply by 12 on both sides. That's going to cancel them out. So 12 times the sine of 60 degrees is equal to x. And then here's where your calculator comes in. Okay, so 12 times the sine of 60 is equal to 10.39, and it asks us to round to the nearest tenth if necessary, so I'm going to round that to 10.4. So x is equal to 10.4, or approximately, because I rounded. Okay, so we can use those trig ratios strategically to find the actual side length without having to do the Pythagorean theorem, because we don't have two legs or we don't have a hypotenuse in the leg. So the Pythagorean theorem can't be used here. Okay, we have to use these trig ratios. Okay, little tip, when you're using your TI-83 calculator, make sure that you're in degree mode. Okay, for both your phone and the actual calculator. You press mode right here, you'll see it. And then the third option down, you have radian or degree. For it to work and work properly, it needs to be in degree mode. We'll talk about radian mode later. Radians is just another way to measure angles, but instead of talking about like degrees, you use actual radians of a circle. It's based upon the radius of the circle is what it is. All right. So the measure of the hypotenuse is 12. Side with the missing length is opposite of the angle measuring 60. The trig function relating to that is going to be the sine function. So sine is opposite over hypotenuse. We plug in sine of 60. And then at this point, they know that the sine of 60 is square root of 3 over 2. Okay, multiply each side by 12. So it's approximately 10 by 10.4. You don't necessarily have to do this step. You'll get the same answer either way. Yeah, they just break it down even farther using the actual specials. Okay. Write an equation involving sine, cosine, or tangent that can be used to find the value of x. Then solve the equation, round to the nearest tenth. So here, we need to pay attention where our angle measure is. It's up here, right? We have the opposite side and the adjacent side. So the function that brings in the opposite and the adjacent side is tangent. So the tangent of 60 degrees is equal to x over 5. Okay, if we use the calculator and then multiply the tangent of 60 times 5, we would get about 8.7, or 5 square root of 3. Okay, once again, they're just setting it up and then solving for the variable. So they're basically the exact same question as that last one. Okay, real world example. This is where trigonometry can be very beneficial, right? Say you're a spy and you need to make sure you have enough rappelling line to get up there. You calculate it, figure out where you can shoot your grapple hook from. So to calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer to measure the angle from his eye to the top of the building. If his eye is if his eye level is about 6 feet, what is the distance from the top of the building to Joel's eyes? Okay, so you can see we have a 76-degree angle here. We're 200 feet as our leg, and we're trying to figure out this other leg. So really we're looking for the hypotenuse. So what trig function is going to fit this? Well, it has the opposite side and the adjacent side. The only trig function that brings both of those in is tangent. So we would set it up that the tangent of 76 degrees is equal to the opposite side, which is d, our variable, over our adjacent side, which is the 200 feet we walked away from the building. Okay, so we can set it up like this, and then we want to isolate d. Okay, so how do we isolate d? We reverse this action. So it's divided by 200. If we multiply by 200 on both sides, we'll get rid of it. So 200 times the tangent of 76 degrees is equal to d. Okay, we use a calculator to take tangent of 76 times two bills. And we would find that the building is roughly 802.15. Okay, and that's from his eye level. So in all reality, that building's about 808 feet because his eye level is about 6 feet off the ground. But they ask, what is the distance from the top of the building to his eye level? Why do they do that? Calculate the height of the building. Why would they use cosine? Huh. That's a little weird. Okay. They use it, I guess they meant to put d as the variable right there. The top of the building to Joel's eye. Okay, so they're talking about the hypotenuse side. Same type of thing. The building's 802. To actually correct it, because I misread the problem. Dang it. So they're talking about the hypotenuse rather than the adjacent side. They asked for the height of the building. We got that, but it's okay. So they use cosine of 76. Like this. Okay, they're placing d as the hypotenuse, so that's 200 over d. And then they go through the process of isolating. First, you have to multiply d by both sides. So your d times the cosine of 76 degrees is equal to 200. And then you would divide both sides by the cosine of 76 to isolate d. So d is equal to 200 divided by the cosine 76 degrees. It's the same process. I just made an unfortunate error because I didn't read the question properly. And you do come up with about 826. It's a very unfortunate place to put that variable. Okay, this one was just a little bit more difficult than using the tangent and actually finding the opposite side. That's because we end up with the variable in the denominator here. So in order to isolate this variable, we have to bring it to the other side first and then divide by cosine of 76. So it just adds an extra step. So they multiplied here to isolate it and then divide it, and they do get 826.7. The distance from the top of the building to Joel's eye. Yeah, that's definitely talking about the hypotenuse. Dang it, dang it, dang it. Okay, to calculate the height of a tree in his front yard, Anand walked 50 feet from the base of the tree and used an inclinometer to measure the angle from his eye to the top of the tree, which is about 62 degrees. If Anand's eye level is at 6 feet, about how tall is the tree? So we want to take all this information. We want to draw a diagram of it. Okay, so we have the tree here. Okay, he walked about 50 feet from the base. Okay, use the inclinometer to find a 62 degree. Okay, and we're trying to find the height of the tree. So here, which trig function would bring all of these in? That would be tangent. So tangent of 62 degrees is equal to h over 50. We multiply by 50 on both sides to isolate the variable. We get 50 times the tangent of 60 degrees, which is equal to h. Plug that into a calculator. Tangent of 62 plus 6 feet is going to be about 100 feet tall. Okay, so you can see how these trig functions, if you use them, and then we can just, because it gets a little, I'd say probably the most concerning part is when you forget that the tangent of 62 degrees is still just a number. You can work it around and bring it back and forth just like you would any other number. Okay, so when it comes to solving them, don't be afraid to actually divide by the tangent of a degree. It's all just still a number. All right, inverse trigonomic ratios. Okay, these we're going to be given a ratio, and then we're going to be asked to find an angle measure. Okay, so as you're reading through those, that is their whole purpose. Okay, we're given the ratio. We use inverse sine, inverse cosine, and inverse tangent to find the angle measure. So if angle A is an acute angle of the sine of A is x, then the inverse sine of x is the measure of angle A. You can see it in the symbols down here. So if sine of A being the degrees, is equal to x, x being the ratio, then the sine inverse of that ratio will give you the measure of angle A. Okay, and then you have a couple examples. It works the exact same way for each one, and this is all very calculator driven. Okay, the hard part with these, or I guess not even the really hard part, the thing to remember is that to access the inverse sine, inverse cosine, and inverse tangent, you have to press second, okay, second, and then right above, and then sine, cosine, tangent. You can see in the yellow it has sine inverse, cosine inverse, and tangent inverse. Okay, but your calculators are going to be very beneficial for you as we go forward. I believe the district is ordering us some more. I'm not sure when they will arrive. So we're not in a perfect system. We're just going to kind of make it work. Once we get them, then we can definitely go forward. Okay, so I'm going to give you a second to write all this stuff down. I've not done too much today. that talking English, now you just got to get it done. Get it done so you don't have homework after practice. Still get it done, Nick. You're not just going to sit here for an hour and a half, man. Okay. Okay. Find the measure of angle A, round to the nearest tenth if necessary. So here we're going to be using any one of our inverse ratios. We could do it however we really want. Okay, what's your question? Great. All right, so trying to find the measure of angle A, we want to round to the nearest tenth. So we can pick any one of our ratios. Okay, we could use cosine inverse and have 14.4 over 17. We could have sine inverse and go 9 over 17. Any of those are going to give you the same answer. Okay, but the key is we'll use the calculators for these wholly. So you know the measure of the sides, you need to find the measure of angle A. Sine of A is 9/17. Okay, so they're going to use sine inverse. So sine inverse of 9/17 is equal to the measure of angle A. And all that is just plugging it into the calculator. We hit second, get the sine inverse, 9 divided by 17, hit enter, and your calculator will give you 32 degrees as the measure of angle A. Okay, if they asked us to solve this, what we got to remember about a triangle is that each one of every triangle, if we were to add up all the measures of each angle, they would equal to 180 degrees every time. So we know we have a 90-degree angle. We now know we have a 32-degree angle, so those added up are 122. So our other angle, which would be, I believe, the measure of angle B here, because C is our 90, A is 32, B would be equal to 58. Okay? But that's just because triangles, if we add up all their angles, they equal up to 180 degrees. Okay, sine inverse is pretty simple. So find the measure of angle B to the nearest tenth if necessary. Okay, use the cosine function, doesn't matter which one you use. The one that I wouldn't use is tangent inverse. That one's a little tough. I would just simply use cosine inverse or sine inverse. That way you know you incorporate the hypotenuse. So cosine inverse of 9/17 gives you 58 degrees as the measure of angle B. Okay. So once again, we pick either one of our cosine inverse or sine inverse ratios. We plug it into our calculator, and we would find the measure of angle A, or measure of angle A, is equal to 30 degrees. Okay, you get 1/2. You can also just remember that from our special right triangles that we had earlier. Let's get to a good one. Okay, using angle of elevation. So a golfer is standing at the tee, looking up to the green on a hill. If the tee is 36 feet lower than the green and the angle of elevation from the tee to the hole is 12 degrees, find the horizontal distance. Okay, so they're asking us to find this base leg here. Okay, so which trig function it gives us incorporates the opposite side and the adjacent side? That is going to be tangent. So we'd set up tangent of 12 degrees is equal to 36 over x. Okay, and then we'd multiply by x. And then we would divide by tangent of 12 degrees. You see how they just move it back and forth. It's just like any other number. And 36 divided by the tangent of 12 degrees gives you roughly about 169 feet. Okay, so that's the horizontal distance. Okay. Roller coaster. From a blimp, the hill of the roller coaster has an angle of descent or an angle of depression of 60 degrees, and its vertical drop is 195 feet. Find the horizontal distance. So here, once again, we just got to ask ourselves, what trig function are we going to use? Well, our angle is here. We have the opposite side and the adjacent side, so we want to use tangent again. And we're going to set it up as the tangent of 60 degrees is equal to 195 over x. Tangent of 60 degrees is equal to 195 over x. And then we'll multiply by x on both sides to get it out of the denominator, right? So that we can finally isolate it. Now we're going to divide by the tangent of 60 degrees. And 36 divided by the tangent of 60 degrees. Once we plug that in, we get 112.6. So that's just how many horizontal feet it's moved. Okay. Here it's this one, we just have to draw a diagram. It says Mario hits a line drive home run from 3 feet in the air to a height of 125 feet, where it strikes a billboard in the outfield. The angle of elevation of the hit was 22 degrees. What is the horizontal distance from home plate to the billboard? So here, we got our guy, little bat. It's Mario. Right? He cracks a home run, and it launches off at 22 degrees. Okay, and it has a peak height of 125. Okay, and we want to find the horizontal distance. Once again, we just set it up as the tangent as opposite over adjacent. So the tangent of 22 degrees is equal to 125 over x. And then we would begin isolating the variable. First, we multiply it on both sides times x. So it's x times tangent of 22 degrees is equal to 125. And then we divide both sides by the tangent of 22 degrees. So that x is equal to 125 divided by the tangent of 22, which is going to be equal to, I think it's like 302 feet. Something like that off the top of my brain. 25 divided by the tangent, 22. Oh, it's 309. 309 feet. Wonder where I made a mistake. Okay, she is 128. Whatever. Okay, Angelina is flying a kite in the wind with a string with a length of 60 feet. If the angle of elevation is the kite string is 55 degrees, then how high is the kite in the air? Okay, so this one, once again, hard part is just making the diagram. So Angelina is right here. Flying a kite in the wind, her string length. Okay, that's 60 feet. That's the kite string. The angle of elevation is 55 degrees. And we're trying to find out how high the kite is in the air. We're trying to find x. So this one is the opposite side over the hypotenuse. So it's sine of 55 degrees is equal to x over 60. Okay, so this one we just have to multiply 60 on both sides, and that will give us our value of x. Plug that all in. So sine of 55 times 60 is equal to about 49 feet. And whenever you're dealing with these word problems, don't be afraid to make a diagram of them. It's a whole lot easier when you can see it. All righty. I believe that is the end of it. Yes, it is. Awesome possum. Okay, so I have already assigned your homework in Seesaw. I believe it's like from page 599. I know we had to go all the way to like chapter 9, I believe, to get into our trig stuff. So you'll be working on that. Your homework is going to be due by Wednesday at 1 o'clock. Okay, that way you have it for our self-evaluation. The numbers are 2 through 38. Your lecture notes are due tonight by midnight, so make sure you submit those, and you can do that all right now. And your bell work lecture notes will hit the grade book tomorrow. Homework won't hit the grade book till Thursday. But I'll leave the Zoom call running just in case you guys have any questions. But other than that, you're off working on your homework.